everyone. Thank you for the opportunity to present today. So my name is Manos Riglis. I'm the VP of Engineering and Systems at Trustpilot. I've been at Trustpilot for just over a year, and I'm looking after our product engineering and our trust and transparency teams. And at Trustpilot, our mission is to be the universal symbol of trust with online reviews. We have over 100 million reviews right now on our platform. A number of businesses and consumers that are visiting our site and using our product. But with wanting to become a universal symbol of trust, one of the things we are working with, and this is one of sort of my functions, the transparency team, is dealing with fraud detection. But what do we mean around fraud detection in the context of a review platform? We're dealing with a lot of different areas, ranging from consumers. So that would be things like spam reviews or reviews that are fabricated and they're not adhering to our community guidelines. Businesses that, for example, might be inviting customers to leave reviews in a biased way. So they might be cherry picking for only the customers that have had a positive experience to leave a review, or they're incentivizing reviews. Or a few other ones, for example, where we had cases where a business would, for example, log in as a consumer and leave positive reviews on their own domain, or leave negative reviews on competitors' domains. And finally, the other part as well that we're looking at is kind of external factors to our platform. So things like review sellers. So you can go and, for example, try to buy reviews, and then there's people that will leave positive reviews on your behalf. And other things like, for example, our platform has been crawled in the past to get reviews out and then sell the content or create APIs on top of it. But for this specific talk, we're going to focus on one part of it. But to give you an indication, we have a number of fraud engines that are currently operating in our platform. And this is kind of a rough categorization. There is a bit of overlap, but effectively we have a number of fraud engines that are looking at content. So they're looking mainly at kind of spam reviews. We have a set of engines that look at fabrication, where a review is kind of not genuine, it's not for a genuine experience. We have engines that look at users, and engines that look at kind of the BUs or the business units. Now, those engines are a combination of both machine learning models and other engines that are more kind of rules-based, and they're looking at different thresholds. And they operate on a variety of data points. So anything from the review content, any metadata on the review, IP addresses of the users, and any behavioral data that we can use to create those models. Every single review that comes into Trustpilot is going through those fraud engines, and then there is a determination whether it is kind of it passes that validation or not. And in the cases where a review might be filtered, in some cases we reach out to the reviewer to say your review has been detected and it's been filtered, and we give the opportunity for users to challenge that decision. At the same time, we have both the businesses and the consumers on our platform being able to notify us of reviews for a number of different reasons. And our content integrity team will check those, and they will take an action, whether they need to filter a review or not. But the other advantage of that is we have a lot of labeled data of like past misbehavior that we can use to train our models and create new engines. But the one thing we're going to be talking about in this talk is around sort of spam. So there was an increase in spam on our platform over the last couple of years. And around Q1 to Q2 last year, we released a new spam model, which was very effective. But then what we started seeing is that the behavior of the spammers started changing. And we started seeing things like that. We started seeing sort of obfuscated contact numbers or email address using sort of Unicode. And there is, it is kind of a cat and mouse game. So with every rule we put in place, with every model we put in place, there is always that attempt to try to bypass it. So one of the things then we started thinking about towards sort of the middle of last year is how can we become better at reacting faster when we're detecting new patterns that are coming in. Obviously, one is to keep on retraining our models, but we want to think how can we can make those decisions faster, and how can we minimize the time that, let's say, a spam review stays on our platform. And that's when we started looking at event streaming. And this is a quote from the CTO, I think, of Smite, which is a company that was bought by Twitter, I believe, and they were looking at spam and fraud detection. And effectively we're saying a lot of things around counting. Effectively, what you're trying to answer is how often, how many. So in our case, it was very similar. How many reviews did we get from a specific IP? Is the content very similar? And we wanted to look at how can we become more real-time and react faster. So in terms of events, so we started looking at event streaming. So what is event streaming? I'm not going to go into a lot of detail. There's a great article called Turning the Database Inside Out that I would recommend. But effectively, events that are published by a producing system, in our case, is a review coming in. They flow through a graph of different processors. The event can be enriched or features can be extracted. It gives you the advantage of doing like windowed statistics. And then it results in an output which basically can go into a data store or it can call out to APIs. And the patterns we started seeing that we wanted to use was things around like, feature extraction, like in real time, in a 5-minute window, how many reviews did we get from a specific IP? How can we enrich those then events? Then we'll start thinking more around sort of feature vectors. So a lot of our model training, as most of you that have been working with ML know, it's like data prep is kind of a big part of the model development, is how can we streamline that and create features in real time. And then the last one was more around sort of controlling that flow. So we've decided to start looking at Google Dataflow, which is a fully managed service. So the advantage for us, it was kind of serverless, fully managed with automated provisioning. It also gave us that opportunity for horizontal auto-scaling of all of the workload resources. And it's also part of the GCP data ecosystem where we're users of BigQuery. We've also been looking at some of the AI platform offerings from GCP. So it made sense to start looking into Dataflow as an event streaming platform. So how does it fit into our architecture? So in Trustpilot, we use both sort of AWS and Google Cloud. And Google Cloud is a lot more focused around some of our sort of more data tech. So effectively, as you can see on the screen, we're using SNS and SQS quite a lot at Trustpilot to trigger different events. So when a review event is created, we have a Lambda trigger, push that review and associate metadata into a Kinesis stream. It then goes into Dataflow. It goes through sort of a validation pipeline that I'm going to show you a bit more. And then that results in a call out to the review filtering API. If we make the determination, the review needs to be filtered. And also then all of the results go into BigQuery that allows us to do some additional analysis of how this is performing. So let's go into a couple of examples, and apologies for like a lot of code on the page, but the pipeline you see on the right-hand screen is one of our validation pipelines. So we start from the top where the source is coming in, so the reviews are coming in, we do some processing, and then at the same time, we're loading what we call the behavioral sort of configuration, which I'll show you in a bit more detail. We go through this validation process and then make a determination whether that review should be filtered or she should be published. In the cases that we need to filter, we'll filter it, and then we make a request back to our sort of compliance APIs to take an action on the review. You will see here we also have this emit to Kinesis again. So in some cases where we cannot find any historical data, we might have kind of some race conditions. If we feel that there is not enough data there for some reviews, we just send it back to Kinesis and go through the process again. The code, as one of the engineers on the team told me, there is a lot of Java here. It's more of a DSL to try to construct this pipeline with code. And then the advantage is here, we didn't have to worry about provisioning sort of workers or anything like that. All of that was handled for us. If we go into some more details on the steps in the pipeline, you can see on the right-hand screen some JSON documents. This is kind of one of our configurations around some of the checks we want to do. So we can specify here, for example, we want to look at the text of the review, and we want to look at the last 5 minutes as the event is streamed through. And we have this threshold of 3. So if we say, we want to check if there's been duplicate text or 3 reviews with the exact same text in 5 minutes, 3 of those, that rule will fail. Similar thing here, where we're looking, let's say, from what IP address this review was created. If in the last 5 minutes there are 5 reviews from the same IP address, that rule will fail. And then it gives us the option to put some more configuration around domains that we want to whitelist, kind of our own IP addresses, and then you can see here there is a number of integrations we have with third parties where we get less sort of spam reviews from those methods. Then if we go into the validation, effectively what we're doing here is we're composing the rules that I showed you before into what we call a trust policy. So effectively, we're looping through all of the available checks that we're doing, and then basically go, did it fail, did it pass, and then enrich that event. So as the review goes through, all of the numbers of checks are run, and basically we're getting that accumulation of statistics to go, it failed on this one, but it passed on that one. And then, as I said before, for example, here we can see, okay, we had X number of content failures, we have X number of behavioral failures, and then the rule we've put in place here as an example is if there is a minimum of 2 failures, then we want to apply that rule and filter the review. And you can see at the bottom is we're composing the string of what policy did we apply, what was the action we took, what was the description, and then it's passed them through into our compliance system. So to have a log of, yes, we filtered that review and we filter it for those reasons. So that gives us a bit more intelligence around what happened. And it also lets our content integrity agents know that if a review came down, this is the reason that, that the review was filtered. So where do we go from here? So as I said, it's still early days. We started this about 4 or 5 months ago, looking at event streaming. We want to start looking at more of how can we take some of our ML models and deploy them into this pipeline, so effectively have more of a real-time inference. More work on window statistics. Right now, for example, we might be looking at 5 minutes. We're experimenting, do we need to have more longer lasting windows or not? A real-time feature store. So as the reviews come in and they get enriched, we can start getting those features and created and then stored for the development of further models. And the last one was more around anomaly detection. So it's a very common use case with event streaming, because as you're looking at the stream coming in, you can start sort of creating some view of what anomalous behaviors are taking place. And I'll pause here for any questions.
Russell asked a question, how fuzzy is the matching? I'm assuming some scores are kind of more meaningful than others, so you wouldn't want to score all filters equally.
Yeah, that's correct. I think a lot of the work we do is when we look at kind of what thresholds to apply, we will look at a lot of our historical data as well, and then we will try to determine how to apply them to kind of minimize, in a way, the false positive ratio. And a lot of it is, in a way, it's kind of a risk assessment that you're making, that do you want to take more risk and perhaps have more false positives, or your thresholds are higher up. Content in our way, for example, duplicate content is a very strong signal. If someone leaves the same review within like the same minute, it's not kind of legitimate behavior. So yeah, so a lot of this depend on a use case basis.